Welcome to the Refactory, Episode 1, starring me and Mr. Parish, my special guest. Hello.
Hello.
Nice to have you. Now, in this series, viewers may remember you from such series as Code Club, which you've been on before, haven't you? And what we're aiming to do in this series is just do some refactoring on Go programs. So it's a bit like the repair shop, but for code. I figure each week people can bring in some program which, is not perfect, let's say. If there are any perfect programs out there, great. Don't worry about it. You needn't bring them in. But if there is anything that you think is less than ideal, we can take a look at it on this show. And I think might be quite fun for people to see if they haven't done a lot of refactoring themselves. What's the process? How do people think about it? How do they approach this sort of thing? Now, people may not even be aware what refactoring is. So perhaps should we just frame it and sort of say, there's development, isn't there, where you're kind of building the program, it's not done yet, you know what you want it to do, but you're not quite there yet. And then refactoring is sort of, the way I think of it is basically it works, but it's not quite good enough, or can be improved, isn't it? What do you think? Is that, how do you approach it? Do you see refactoring as something that you constantly do while you're working on programs, or is it something that you kind of get to the end of the program and you think, right, now I've earned a big session of refactoring?
I actually refactor every other minute or so.
Yeah,
I
me
think I'm
too.
paranoid.
Yeah, I know. Well, the thing is, I know people who just, they write their program and it kind of works and it does what they need it to, and they're like, why would I worry about refactoring or whatever? Like, what's the point of that? And I sometimes sort of half jokingly refer to refactoring as sort of, any software engineering activity that delivers no business value, or, or no tangible value. Let's say, if you show it to the manager and they're like, I don't see any new features here, and I didn't see that you fixed any bugs, but you've been doing, you've generated a lot of diffs. I see a lot of commits here. What have you actually
Yeah,
been doing? How could we answer that?
I guess that's why we want to know.
Yeah, I mean, we'll see some examples because we're going to go through a project of yours and try to refactor it a bit. And but I think, what I'm primarily looking to do is, I had in mind what I wanted the code to achieve, and it has achieved that. But now that I've done that, I know I can rewrite the code in a better way to achieve the same goal, sort of thing, isn't it? Like, I'm sort of
Yes.
partly working out how it should behave while I'm writing it, and then by the time I've
Yeah.
got a working program, I've got a much clearer idea of what the behavior should be, and I know how to deliver that in much less code, and I
Yes.
can tweak the names of things to be much more informative and logical, and I can change my API around and move things into different packages or whatever so that it's clear and simple and readable, and it also makes a really solid base for future development, isn't it? I mean, if you're literally just going to
Yes.
use this program once and then throw it away, fine, don't worry about it. But most sort of most non-trivial code does sit around for a long time and gets built on, developed, new features, bugs get fixed, other people use it in their projects, and so forth. So refactoring is all part of that quality process, if you like. As you build the next story on the house, you kind of settle everything down so that it forms a solid base for the next bit. And I think your attitude is absolutely right, that it's something we should do continuously as we go. No point
Yeah.
waiting to the end of the project, because when did a project ever end?
Never.
You never get done, do you? That's the
Yeah, you
thing.
never
So
get that.
just say a word or two about this project. What's the inspiration behind it? What does it do?
Well, the name of the project is Fupisha. Fupisha is a Swahili word for shortening something.
Great.
So I chose that name because it goes in tandem with the description of what it will do, which is shortening URLs. So my main motivation was I wanted to involve everyone in Nairobi Gophers, which is a group that deals with or focuses with Golang in Kenya. I realized that in the group there are very experienced, folks, and getting these folks, involved with other people that don't have that kind of experience. I realized that you can't do that with just talking in the group. We needed something that acts like a common ground for both sides, the experienced and the non-experienced folks. So I decided to come up with this project. I myself, being, just like the intermediary, I'm not that experienced, but I also wanted to learn. So I involved the community and I decided to start it and then at least get something working, then invite others to join.
Yeah, that's a wonderful idea. I wish more people would do this. And it's something everybody could do, isn't it? Everybody has some local Go meetup or other programming group, and it's nice to have talks and chat and so forth, but it's also great to kind of get people involved in projects. As you say, there will be people there who are super experienced and know a ton. The best way to download that knowledge from their brains into ours is to work with them on something, isn't it? And for the people who are new, maybe not feeling at all confident, never really written any non-trivial programs, they maybe wouldn't have the confidence to launch into something like this by themselves, but they would love to join in with a community project like this. So that's great. And you yourself are sort of, you don't have an immediate need for this particular service yourself, do you? But it's sort of like, this is something like a URL shortening service, kind of touches all of the major things that most Go programmers need to do, isn't it? We're doing HTTP, we're storing stuff in a database, we've got multiple layers and probably multiple packages and some testing problems, I'm sure.
Yeah,
there are always
exactly.
testing problems.
Yeah, like we shall see in the project, actually, there are a couple of them.
Yeah, so this is a very well chosen example, I think. So should we just walk through? You yourself will already have some feelings, I guess, about areas of the code you're less happy about, things that you want to fix, or that you think could
actually
be done better.
given my imposter syndrome levels, I think the whole project, given that I did it in a hurry, I just wanted to get something out there, get it working and involve people. I'm not really confident about the whole project, but I'm confident that it works. That's my main goal, that it works, even though it's not yet completed.
Yeah, and you know what? I think that's the exact right way to go about it, is just to do something, even if you're not sure exactly what to do something, see if it works, improve it as you go and add features, and it's much easier that way to work out if you're going down a dead end. If you're trying an approach which basically is not going to work out in the end, you don't want to sink 6 months development into that before you find out it's the wrong approach, do you? So we used to call this,
for this project, I took way longer than I should have.
yeah, that's true of every project, I'm sure.
Yeah, with the pandemic and everything, I took longer than I should.
Yeah, we used to call this sort of process agile, didn't we, until that term became deeply unfashionable. But I can never understand why people argue against being agile, because what's the alternative? being sluggish, being clumsy, I don't know.
An agile, if there's ever such a term.
Yeah. So I've found, as in my sort of mentoring and teaching work, or even consulting, there's always a lot of refactoring involved. And what I used to do is I used to say to people, show me the program, I'll tell you when I see something that we can fix. What I do now, which I think is a little bit cunning, is I say to them, you tell me what you think is wrong. And I'll tell you if I agree, That way, you don't you don't run the risk of bruising someone's feelings by, they
Yeah.
think they've got the world's most wonderful program, and you start finding all sorts of things. It's only tiny things, isn't it? Like, just maybe this variable could be a slightly different name or something. But if you have 500 of those little comments, it's possible to feel quite demotivated about your wonderful program.
Yeah, actually, very, very easily to be demotivated by such comments.
So yeah, well, let's start that process then. So where shall we start in the code
I
process?
think, should I first show you like like go through the architecture, not even the architecture, this the directory structure.
Well, maybe
Um,
not actually. I mean, I sometimes think a better way to approach
okay.
these things is to start with the very highest level code. If you have a binary, then start with main, see what that calls, work your way through that. And if you have tests, start with those tests and see what they call. And then
Okay.
you sort of work out the architecture from that, won't you? If it's well organized, you'll know,
Sure.
and if it's not, then you'll also know.
Yeah. Let me start with the entry point, the main entry point of the project.
Hmm.
We have, this is our main package.
Yeah.
The main package, its main purpose is to set up things, set up the API server, set up the command line configure command line parameters,
Hmm.
set up you know uh, the flags that are needed for the command line, UI.
Yeah.
And yeah, that's pretty much it. But
So,
the gist of the API is in the new server call method
hmm.
call,
Yeah. So
which
basically, so this binary sort of starts the server, and then the server sits there. You can make requests to it, and I guess it
yeah.
will unshorten URLs, probably what it's doing most of the time, and also shorten them.
Yeah, currently it's not unshortening, it's just shortening.
Right.
It's a work in progress actually.
Yeah.
Currently it's just shortening.
Yeah. Well, that's
Yeah,
okay. You don't need to talk it down. Like,
yeah,
as we were saying, it's never done. It's always
yeah,
representing some point in progress. But
yeah,
it's useful to know, how many of your goals you've so far achieved.
I agree.
And the main looks very good. So it's exactly the kind of thing that I like to see with a well-organized project. In that there's not much there.
Yeah.
If you flip back to main.go for a minute, we can
Okay.
see that basically we're in package main, which we need to be if we're going to build a binary, and we have a func main, which should be called automatically, and
Yeah,
we don't really do a whole lot except import some package and kick it off, isn't it?
yeah,
API,
yeah,
new server. Basically, the only things we need in main are about, do we take any flags, any command line arguments,
yeah.
things like that. It's about being a CLI, isn't it, rather than
Sure.
doing
Yeah,
any business logic.
yeah,
And that
exactly.
makes sense because people can't import your main package.
Yeah.
So any code in there is useless to anyone except you.
Yeah, I
so
agree. I agree.
so if there's something important in main that people might want to import and use, then it should probably be in some package. And that, it seems obvious when you frame it that way, doesn't it? But nonetheless, I see main.go that goes on for hundreds of lines, and it's setting up this and creating that and configuring something
Oh,
else and doing this. And the other thing is, how do you test that? Because you can't really, can you?
yeah, you can. Actually, that's what motivated me to have a small main, because testing becomes hectic when you have a main that spans more than 50 lines.
Yeah. So I'm rating this 10 out of 10.
Okay. I'm I'm really, I don't know what to say. That gives me the confidence I need to continue with the session.
Yeah.
Okay, let's go to the API package.
Hmm.
Um, I'll follow the new server. Now, the new server method, actually, it's a function, a factory function that sets up the server,
Hmm.
sets up everything that the server needs, and returns to you a ready to use server instance, which is a pointer to the server struct.
Yeah.
So here we set up the config from the environment variables. Here we initialize our database, our store. Here we start actually the instance, the API instance that will handle the routing and everything that HTTP related. And then we return that instance to the API variable, which actually is a router.
Yeah.
This is a router. Then the API will handle everything HTTP related, as you can see here in the HTTP server struct. So basically are bootstrapping everything here and returning a ready to use server instance.
That's great, very clean. So if we think about most Go programs, they're usually servers of some kind, aren't they? Unless they're clients for somebody else's server, which is probably written in Go. And sometimes we're writing both sides. So usually it's like there's a sort of a three layer structure, isn't there? Like a delicious cake. Like you've got some business logic in the middle, which is about the thing that the project is about, URLs or whatever. And then there's like, but we need to serve that some way, so we need an HTTP server layer on top of that. But the HTTP server knows nothing about the business logic. All it does is just call into some other package, the middle package. And then, you know, sometimes the server is stateless, which is great. That's so much easier to manage, isn't it? But, you know, often we have to store some persistent data somewhere, usually in a database or something like that. So we have some storage layer underneath. And again, the business logic shouldn't really know anything about how that works, should it?
Yeah.
It should just be completely decoupled, and it's just like, I just have some kind of reliable data store object that I can just talk to and say, get me the data, okay, here's some data back. You know, that makes it really easy to swap in different implementations. Maybe it's Postgres, maybe Mongo, SQLite, something like that.
Exactly my thought. Actually, that was the main idea behind this get store. You'll see exactly what you've said. It's what I've done here.
Perfect.
You just see, yeah.
So this is a beautiful demo of what I think is sort of the ideal architecture. It's very common to see, you know, sometimes you've got, you know, you've got all of your business logic mixed up with specific knowledge about how the database works. You know, column types or SQL or something like that, and it's also mixed up. And you've got this code inside an HTTP handler, so it's, you know, it's also tied in with the server layer, and it's all in main. You know, like there's any number of ways to get this wrong, isn't there? So,
yeah, that's very, very tight coupling there.
Yeah. And it feels easier when you're doing that. This is the problem, isn't it? Because it's seductive. It's like, I know exactly what I need to do. I need to make a Postgres query or whatever, so I'll just do it. But the more you go on like that, the more you get to a place where you just realize, I'm completely stuck. You know, I'm unable to change anything because the tentacles reach out through the entire program.
Yeah, actually.
Anything you change, it just starts unraveling somewhere else. And you're like, oh my God, this is an unmaintainable nightmare.
Yeah, it becomes a big ball of mess.
Yeah, I've done a few consulting projects like that. But admittedly, they don't tend to call me in when everything's fine. But it's good to start the right way, isn't it?
Okay, yeah. Okay, to now continuing, here we have the start method declared on the server struct. Essentially, you know, once you return this server, you would want to start it. It's obvious. So it's obvious that this start method be declared on the server struct, and because the start will also need to access some of them member variables, member fields of the server struct. So that's exactly what we're doing here. We are starting the API, the HTTP server here in its own Go routine because it's a blocking call. So I'm setting up the server here, and we also need to take care of, you know, when you want to terminate on the terminal with Control-C, we handle the all signal interrupts here. Then here, once I think this is something I needed to think about, and I will ask it here. I was contemplating on putting some logic on how to propagate the signal, the interrupt signal down the request chain to all the handlers, like if you terminate the server while there's some request being processed, the request can be able to receive the signal to shut down. But before shutting down, it needs to first finish whatever it's processing and shut down in a clean state.
Yeah, and that's
So
normally the default. The default behavior of servers is usually to say, if I probably have some flag, don't I? That I have some bool somewhere that says shutting down. And if that's true, then I let existing requests complete, but I don't start any new ones.
Yeah.
So I don't kind of interrupt the request handler and say, hey, we're shutting down, because what's it going to do? It just needs to finish its job anyway, isn't it? So
exactly.
we could do it through context, of course. If there was something that, like, you could imagine emergency shutdown, the data center is on fire. Please save. You don't have time to finish the request. Just save everything and quit. You could do that with context.